Hello guys, welcome to my series of solving miscellaneous questions, one question per day. Okay, so this is a class 12 question, and the question is find the percentage change in the resistance of a wire if the length is made double by stretching it. I have seen this question a lot of times in exams, so let's solve this question. Okay, now, resistance, right? So how about you try this question, pause the video for a minute and try this question if and then match the answer. And if you can't, then feel free to take help from my video. Okay. So I'll be solving this question for you. So resistance, right? Now, resistance of a wire R is equal to rho L by A. So L is the length of the wire, A is the cross section of the wire, and rho is the resistivity of the material of the wire. Uh, Now, what are we doing? We are doubling the length of the wire. So let us say that the initial resistance is Ri. That is our initial resistance. Or you can say original resistance, whatever you want to say. And Rs is my final resistance. And we need to find the percentage change in the resistance. So for that, we would need to find what is the value of the final resistance. So I know that the length of the wire is being doubled. So that means if the initial length was Li, the final length would definitely be twice of Li, right? But how do we know what is the change in the area, right? I have changed the length, but what will be the dependence of changing the length on the change in the area? So I know that अगर मैं length को double कर रही हूँ, if I'm doubling the length, then the volume of the wire would stay same, right? Because I'm not changing the area. The length of the wire is being changed, but the volume is kept constant. So that means if the volume of the wire was VI, the final volume of the wire is also equal to VI. The volume remains same. We are not changing the volume of the wire. So how do you write the volume of the wire? So volume of the wire is equal to the area of cross section into the length of the wire. Okay. So that is how you write the volume. That is the formula for your volume. So if the volume of the wire remains same, that is VI is equal to VS. So from that, we can say that AI into LI is equal to AF into LF. Okay. I know that the length is being doubled. If the length is being doubled, so AI, LI, so it will remain same, and AF we need to find, and LI is what? Oh, LF is what? Twice of LI. Okay. So this Li and Li will get cancelled, and we will get AF is equal to A by 2. So we have that if the area of cross section of the wire was AI, initially the final area becomes half of AI by 2, right? That is what we get. Now we need to find what is the final resistance. To find the final resistance, we will use this formula and we will have RF is equal to rho LF by AF. And what was our initial resistance? The initial resistance was rho Li by AI. So now what is LF and AF? We will put in terms of Li and AI. So LF is just twice of Li. So let me just put twice of Li. And AF is what? AF is AI by 2. So if AI by 2, 2 is in denominator, it will go in numerator and we will get it as 4 rho Li by AI. Now, what is rho Li by AI? So we have written that rho Li by AI in the above formula is Ri. So that means this is equal to 4 times Ri. So what is the value of the final resistance? The value of the final resistance is 4 times the Ri. That means if I am doubling the length of the wire, the resistance is being increased 4 times. Okay, so the resistance has increased 4 times. So let us write that if my initial resistance was Ri, okay, initial resistance is Ri, the final resistance which we called RS, is actually 4 times RI, right? It is actually 4 times RI. And if it is 4 times RI, we need to find what is the percentage change in the resistance. That is what the question is asking. What is the percentage change in the resistance? And what is the percentage change? So how do you find the change in resistance? So we have change in resistance divided by the initial resistance into 100. That is how you find the change in resistance. So what is change? Change is RS minus RI. The final minus the initial gives me the change. Initial is RI into 100. That is what we need to find when we are finding the percentage in the resistance. So RF is what? RF is 4RI. RI is just RI. And we have in denominator RI into 100. So 4I minus Ri will give me what? It will give me 3Ri by Ri into 100, which is equal to 300%. This is equal to 300%, which means that when we are doubling the length of a wire, the resistance is being changed by 300%. The resistance has increased by 300%. So we will write that the resistance has increased by 300%. That is our final answer for the question of the day. Thank you so much, and I hope to see you all in the next question of the day. Okay, that is tomorrow. Bye bye, guys. Keep learning, keep studying. And if you like my video, do like and comment on my video and share my video with your friends. And don't forget to subscribe my channel. Thank you.